It is a great privilege to be here. I hope that I can convince some of you that I'm not totally nuts. The relation of philosophy, mathematics, and physics is truly curious. It brings together three people who are usually not thought of together. Ludwig Wittgenstein, philosopher and mathematician, who we'll hear more about as we go along. John Archibald Wheeler, who was an eminent theoretical physicist, primarily working in gravity, but also, as we will see, instrumental in a philosophy of quantum mechanics. And David Foster Wallace, who's a notable author and writer, but who unfortunately committed suicide in 2008. Shortly after that suicide, I Googled David Foster Wallace, which is the way everyone starts anything these days, and I found, the first thing I found was his address to the graduates of Kenyon College in 2005. This has led to a book called What the Hell is Water? And the book repeats his address one sentence at a time on each page so they could fill up a book. It's something which would have horrified David Foster Wallace, I think. The title of the book is What the Hell is Water? When I pulled it off the internet, it was in the public domain. It has since vanished from the internet and vanished from the public domain. So you have to watch for these things. There are a lot of things like that I found in this. Anyway, it refers to a quote from David Foster Wallace from this address. There are these two young fish swimming along, and they happen to meet an older fish swimming the other way, who nods at them and says, "Morning, boys. How's the water?" And the two young fish swim on for a bit, and eventually one of them looks over at the other and goes, "What the hell is water?" And the idea, of course, is that when it's everywhere around you and completely obvious, you all have to be outside it to recognize it. And for the quantum field theorist in our midst, I mean, it's equivalent to asking what the hell is a vacuum state. David Foster Wallace, his first novel was a novel called Infinite Jest, which is suitable for propping children up to the dinner table. It's 2.5, 3 inches thick, thousands of pages, and extremely clever. After Infinite Jest, he wrote a number of articles for Harper's in the period after Infinite Jest and even before. One of the most famous, which is I don't know if it's still in the public domain or not. It's one that is he followed the first George Bush campaign in 2000, and wrote a journalistic article for Rolling Stone about that. After Infinite Jest, he did not start another novel for some time. As a matter of fact, his last novel has just been published posthumously. and in between, he wrote this booklet, as he called it, called Everything and More. This is a compact history of infinity. The book begins, it's written in David Foster Wallace style, so it has lots and lots of footnotes. And the first footnote is of interest here. Your author here is someone with a medium-strong amateur interest in math and formal systems. He is also someone who disliked and did poorly in every math course he ever took, save one, which wasn't even in college, but which was taught by one of those rare specialists who can make the abstract alive and urgent, and who actually really talks to you when he's lecturing, and of whom anything that's good about this booklet is a pale and well-meant imitation. That's a very interesting disclaimer, and one which the pure mathematician or the well-trained mathematician has to keep in mind. It's not really a book about mathematics. Everything and More is a book about the danger of abstract thought. Abstract thought is, according to David Foster Wallace, abstract thinking tends most often to strike during moments of quiet repose, as in, for example, in the early morning, especially when you wake up slightly before the alarm goes off, when it can suddenly and for no reason occur to you that you've been getting out of bed every morning without the slightest doubt that the floor would support you. Now, this plight of the abstract thinking, it's the dyslexic, agnostic insomniac who lies awake all night wondering if there's a dog. That's pretty funny. And also worries, will the floor support me? Now, why would the floor have supported you every morning when you got up for thousands of mornings? And presumably you're not really worried about you supporting me this morning, but you don't have a proof. You don't have a proof that what might happen to you is what happened to Cousin May. Because some primal termite knocked on wood, tasted it and found it good, and that is why your Cousin May fell through the parlor floor today. That could happen to you, but you don't worry about it unless you're a dyslexic, insomniac, agnostic. The problems of philosophy and mathematics, we've got a history. This is David Foster Wallace's order here. He talks at length about the Greeks, about particularly the Eleatics. Zeno, who was the most famous, his predecessor Parmenides, who was his teacher, and Zeno proposed 4 paradoxes, most of which all of us think were completely resolved by the studies of motion in the 18th century by Newton, by all his successors. I mean, one of these was how do you get across the street if you can't get halfway? Because if you get halfway, you must have been halfway to halfway, and so forth and so forth and so forth ad infinitum, and you got an infinite number of terms, and how do you know it comes out that you can get across the street? And of course, you know, someone like Plato would just get up and walk across the room and say, there, that's how you do it. You don't worry about this is the kind of situation where the mathematician philosopher gets out of bed. And that I really love the Monty Python Philosopher song that many of you may know the lyrics and recognize them. But it's very irreverent and somewhat on the money. In Plato, it's a drinking song, of course. In Plato, they say, could stick it away, half a crate of whiskey every day. Aristotle was a bugger for the bottle, but he also formalized logic. And at one of the peaks of this is the work of Euclid. There aren't even any stone statues of Euclid anywhere. As a matter of fact, he's a very shadowy existence. It's not clear exactly in what sense there ever was a Euclid, although his book, The Elements, was used as a geometry textbook. My father used it as a geometry textbook in high school. And Euclid he followed this Aristotelian idea that you made definitions and then you made axioms about how the things went together. And the things he defined were points, lines, planes, things like that, intersections of lines, and he founded geometry, and he put it on a logical basis. And it's how most of us actually had our first introduction to what constitutes any kind of a logical proof, is geometry. The definition of a point I don't think has ever been improved on from Euclid. Nobody knows what one is exactly, but it's that, according to Euclid, it's that which has no part. That is, it is that thing which cannot be subdivided somehow. And that's about as good as we can do, but Euclid made great progress in axiomatic structure of connecting points to reality. Usually when I do this, I have another prop that I couldn't bring with me from Florida because I'm sure you can't take it on an airplane. There's a box of objects I bought for $1 at the disposal counter at an Office Depot. It's called mathematical tools. I thought everyone should have a box of mathematical tools. And the first thing it has in there is a point maker. And it's a pencil, of course, that you put on the paper, and it makes a point. But of course, according to Euclid, all you got to do is imagine a pencil with no lead, and that's what makes a point. It has only its location. And he also had things which there were things in there that baffled the Greeks, baffled me for that matter. That Plato was bothered by the fact that if you make a right triangle with equal sides, the hypotenuse has length the square root of 2 times the length of a side. And he could draw a picture of an isosceles right triangle, but he couldn't figure out how much was the square root of 2. There was no representation of it other than this. And the problem is that it's an algebraic irrational number, and that just the decimal expansion goes on and on and on forever, never stops, never repeats, and so forth. And that was in the box of mathematical tools too, as was a straight edge and several other things, including a compass, which I'm sure would be the thing that would block you from taking it on the airplane because it's got a sharp point. I didn't ever try it. It would be worth a try sometime to see what happens if they impound mathematical tools to keep with all their knives. The end of finally the Greeks, it comes down to pretty much the last of them was Archimedes. Archimedes of Syracuse. This is a painting from the 17th century, and it's supposed to be Archimedes in thought. And there are many anachronisms. As a matter of fact, virtually everything is an anachronism. Archimedes wrote on scrolls, or he did his scribbling in the sand. The work of Archimedes there's recent interest in one of these Google lectures at one time was about the Archimedes Codex. I don't know if anyone was here for that, but the Codex is a book whose pages are made of parchment, which is scraped out leather, and this Codex was written over in the. It was originally copied from a scroll, an Archimedean scroll, probably in the 7th century sometime. Archimedes, when he did his work, when he wrote down all his things, he actually computed to several decimal places the perimeter of a circle of unit radius, and he did this by inventing essentially calculus. He just essentially the epsilon delta method. He just got closer and closer and closer. He lower bounded it and upper bounded it by regular polygons, and got finally what he reckoned was close enough. But all these things were written on scrolls. This particular codex was one of the scrolls that he shipped off to the great library in Alexandria to his friend Aristophanes, who had subsequently, of course, the scroll was destroyed, as was everything, but something survived, at least to the point where in the 7th century, someone copied it onto a parchment codex, which is like a book. And the codex was eventually turned into a prayer book, which is why there's a fold down the middle. The Archimedean text runs along the minor axis, and the book text runs. The book text in Greek runs along the major axis, and or book text in Latin, excuse me. And it was all painted over and carefully illuminated. And the lecture here at Google was by the people who cleaned off and scrubbed the codex and read it eventually and found out what it said, which is. But these things were shipped back and forth around the Mediterranean, and it's often said that the principal Roman contribution to mathematics was the assassination of Archimedes. He was killed during the siege of Syracuse by a Roman soldier who had orders to bring Archimedes before the Roman conqueror, and Archimedes said he was busy. And he talked to him later, and so the soldier killed him, because you don't disappoint the government. And that kind of ended things for 1,400 years through the Dark Ages. And things didn't really awake until, well, I give Descartes a lot of credit for coming to life, bringing it to life. He was the one who said really that abstract thought was part of his personality. That is, part of what made Descartes Descartes was, I think, therefore I am. Which, there's a story of Rene Descartes is in a bar having a drink. He finishes his drink. The bartender says, "We have another Mr. Descartes." And he said, "I think not," and vanished. Monty Python says, "I drink, therefore I am." Now, two people arrived on the scene at approximately the same time with similar ideas. And the two mathematicians, physicists, philosophers, all three, who really not only got out of bed and had the floor support them, but they danced on the floor. Newton said this peculiar statement down here has all kinds of symbols in it that no one had thought of before. As a matter of fact, Newton, I don't know, he says there's an equation there, R dot. R is a fluent, according to Newton, and R dot is a fluxion, according to Newton. We call them functions and derivatives now. On the right-hand side is a limit as delta t goes to 0. Now, something going to 0 says its reciprocal is infinite, so it's again another backhanded infinity coming in. And it appears in the compact history of infinity. In fact, it's probably the part of the Everything and More that's really, to me, the best is when he does discuss calculus, which he does in a couple of pages. The other giant of this time is Gottfried Leibniz, and I'm going to bypass what he said for a few minutes and jump through roughly 150 years when serious mathematics has become a part of everything, part of all reason, part of all philosophy, part of everything that was going on. And I'm going to just do this discussion with a new guide, with someone to help David Foster Wallace along. And our guide is going to be Bertrand Russell. And Russell wrote a remarkable autobiography that covers his whole life. And it was all in three. The only unfortunate part about it is that he wrote it, as autobiographies just about always have to be written during your lifetime. And he wanted to protect a lot of people whose reputation he didn't want slandered, because by the time Bertrand Russell died, he was viewed as a paragon of evil, particularly in the United States. So he didn't want to slander a lot of people, particularly women and other philosophers. So he left them out of the autobiography. But Fortunately, we have an alternative an alternative biography, which is a thing that's different in every respect from, it's logicomics. It's this thing, this book, which is by reckoning of its authors a comic book. It's a graphic novel. It's a graphic story, and it's a very good story. By the way, this shows you another thing that's really screwy about copyright laws, and I know they're dear to the hearts of Google, but in logicomics, every time Bertrand Russell appears with his pipe, he has it in his right hand. Here, he has it in his left hand. All pictures that I could find, photographs I could find of Bertrand Russell with his pipe were copyright protected if he had it in his left hand. If he has it in his right hand, you can use them. You figure. Logicomics. Here is the cast of characters at Logicomics. Gives a lecture which is supposed to be the role of logic in the affairs of man. That is, the curious relation of logic, mathematics, and physics. And he says, you know, really in the affairs of man, if I gave this lecture on that subject alone, it would be the shortest lecture of all time, because there is no logic in the affairs of man. So instead, he says, I'm going to tell you a story, and it's a rattling good story. It's a story of my life in logic. And thenceforth, it's pretty much all, logicomics is pretty much all fiction based on fact. The authors of logicomics relied heavily on the two biographies of Ray Monk, himself a philosopher in England, the biography of Wittgenstein and the biography of Russell. The liberties that were taken took Russell from England through Europe with his first wife Alice, who is a lady with a funny hat in the background. They went to Europe in 1900, which they really did, but Logicomics has him visiting in the flesh Frege, and also visiting Cantor, neither one of which he ever met. And the trip through England brought him in contact with all these other people. He and Whitehead finished Principia Mathematica, and it was sold that he and Whitehead had to pay for the publication. The publisher wouldn't deal with it, and but Principia did circulate, and in the Logicomics, he is visited by Ludwig Wittgenstein, who came to him by way of Frege to study logic. Gödel, I guess, briefly in 1944, before he went back to England. But in the main, it's just a good story, and not much of it. I mean, if the seamy parts of all his romances, I think, are probably all in either in his autobiography to some degree or in the biography by Ray Monk. In any case, Wittgenstein was entranced by the problem that was unsolvable, the the Russell's paradox about the village where the barber, there's only a single barber in the village, and that barber shaves everyone who doesn't shave himself. And the question is, does the barber shave himself? Yes, and if he does, he doesn't. If he doesn't, he does. That's the Russell's paradox. And Wittgenstein, Russell, and everyone thought that this was a solvable problem. And for some reason, it skipped that page. And Wittgenstein, I'm going to put that up for a minute, because Wittgenstein spent the First World War in the German army and was in the trenches. He wrote a thing which he eventually brought back to Cambridge, and he said that he had completely resolved all problems of logic. This thing was eventually named by G.E. Moore, who was Russell's colleague at Cambridge, was named Tractatus Logico-Philosophicus. And it's a very strange document. It's available on the internet. You can download it. It's not copy protected. And Russell and the publishers looked at it and said, this is actually word for word part of the abstract. The abstract has seven lines in it. He calls it an abstract. And each of these leads somewhere. There are some cases only a few sentences for these lines. In some cases, there might be a page. Most of the actual philosophical meat, the actual logic, resides in 4, 5, and 6. So I didn't put those up. Although he tried to express them in words, the eventual result was that Russell had to write a preface for Tractatus. The publisher said they wouldn't take it unless Russell certified that there was something to it. So at least in one of the things that's available on the internet, you can find Russell's introduction to the Tractatus, which is about the same length as the Tractatus itself, but which many say is the only part that makes sense, that you can understand what Russell said, but it's really hard to understand Wittgenstein. Wittgenstein's own synopsis, however, is interesting. That this he gives in his introduction to it. What can be said at all can be said clearly. Whereof one cannot speak, thereof one must remain silent. That is, the fact that there's an elephant in the room in the person of Russell's paradox, and its related friends, you just ignore it and go on, and you can do a lot of useful things even when you ignore the fact that there's this paradox residing in the background. Now, for the record, logicomics and everything and more end on the same note. With respect to infinite sets, with respect to the curious relation of philosophy, mathematics, and physics, that Gödel and Cantor both died in confinement, bequeathing a world with no finite circumference, one that spins now in a new kind of formal void, And mathematics continues to get out of bed, following Wittgenstein's dictum. That is, ignore. Gödel's contribution, of course, was the Incompleteness Paradox, that if with every set of logical rules, there exists unprovable, undecidable propositions, which are themselves tautologies and should be part of the fabric. If you're going to get my paraphrase is that with logic, you get the truth and nothing but the truth. You just don't get the whole truth. And but back to this parallel universe, which I think really is different. Leibniz might have said, and if I were to write a logic comics, I'd put Leibniz in there saying this exactly, that the derivative of a function is itself a function, which is the derivative, and that function is a function of a complex variable, that f of z plus delta z minus f of z divided by delta z is f prime. And that f of all functions have both a real and an imaginary part, and that is to say f of z, the derivative of f of z also is a function. And you put those two things together. Now, the same 150, Leibniz didn't say that. He did define the f of z, df dz, to be a function. He understood that. It's not this business of fluent equals fluxion. It's one function equals another function. They're the same thing. And again, the same 150 years passed, and in the same 150 years, things were pretty much the same as they were with Newton's view. But what about this x squared equals minus 1 thing? And some said it was just a matter of convenience. Some, like all the engineers, call it J. Some took it seriously. And among the people who took it seriously are Cauchy, Riemann, on through my idol, Arnold Sommerfeld. There's a straight line to John Archibald Wheeler. Sommerfeld had the most remarkable set of students and research associates that anyone ever had. He had 4 Nobel laureates, 20 or so of which were famous in their own right beyond, famous for Peter Debye, people like that. I mean, the list is incredible. And he also had some research associates who were quite well known. One of those research associates was Hertzfeld, who was Wheeler's advisor, his thesis supervisor at Johns Hopkins. And Wheeler himself had quite a remarkable set of students, among whom were Hugh Everett, who was at North Carolina, and Richard Feynman of Caltech, and a number of other quite notable students. I pulled out this quote because this is this is typical Wheeler. That Feynman, I know why all electrons have the same charge, because they're the same electron. And what he was talking about was that if you draw the path of a single electron through space and time, and you imagine that the single electron can go both forward and backward in time, then if you take a slice in time across, you get it's all the same electron, so they must all have the same charge, because some of the times it's going forward, sometimes it's going backward. And everybody realized, well, gee whiz, that means that that there are such things as an antiparticle of an electron, and they said, you know, there's going to be as many positive charges as negative charges, and that's a typical Wheeler. He ignored the elephant in the room, and he says, well, maybe they're stuck on the protons or something. In the late 1980s, Wheeler became very interested in quantum computing, and he wrote a paper which is also goes in and out of the public domain, called it was for an IBM symposium, and I don't understand the paper, but I do understand his puzzles. The paper is called "World as a System Self-Synthesized by Quantum Networking." I think, you know, you might call it Tractatus Logico Quantum Mechanicus. If the world is founded on a discrete, why does every workaday description of it have to employ the continuum? How does this quantum state function get into the act? How do we reconcile the demand for structure with the demand for austerity? Austerity, I think, simply means that you have the absolute minimum number of axioms to get anywhere, which is probably one. And how to derive time without presupposing time. All philosophical puzzles. And all we need is an austere, timeless statement of quantum mechanics. Now, what I have been trying to do, and what I'm doing here, is trying to engender a point of view of quantum mechanics that's consistent with my thesis supervisor's book, the Elementary Quantum Mechanics by David Saxon. I have been trying for several years to make myself a web page which has a lot of things on it. Like a lot of the things that are in this talk but aren't not yet on there. I don't know what's going to happen to it. I don't know what's going to happen to it because I did it with iWeb on Mobile Me, where you get a web page sort of for free. And Apple is ending all of that, so my web page will end, and I don't know where it will go. But at the present moment, it's on there, and so is Elementary Quantum Mechanics, that Dave, before he died, gave the copyright to. He really opened it up. He gave it to us, said you can do anything with it you want. One of the things I have done is you can download it off my web page. Which the important part of the structure is that very early on, Dave Saxon introduces the notion of the Debroglie wave function for a structureless point particle labeled by a coordinate x. And he writes down the familiar form of the Debroglie wave function. It is a time-dependent plane wave, and says, so that there be no misunderstanding, we state as emphatically as possible that the quantum mechanical rabbit is already in the hat once equation 1 is accepted and understood. That is, this is the single thing that defines quantum mechanics. This is not what we're used to, but it's the way this book is developed. And in relatively short order, Saxon shows us that the time-dependent wave function can be a superposition. In general, is a superposition of these Debroglie waves, and that the time derivative of the integral of psi star psi is 0, something which you can easily establish for yourself, confirming that x is a continuous random variable. Now the trick with this time derivative is, for those who are, you have to slip the time derivative under the integral sign and find some relation between the time derivative of psi and its spatial derivatives, which is supposed to be a de Broglie wave. And that confirms that the x in the de Broglie wave, the position variable, as it's called, is a random variable, a continuous random variable. We know it's continuous, is that you can even make it a complex variable. If you're going to talk about derivatives in the sense of Leibniz, where the derivative of a function is itself a function, then you have to think of it as a complex variable. But it's confirmed as a continuous random variable, and one which can be analytically and analyzed as a complex variable. And the probability, the integral of psi star psi over all values of x, which I just said there's some domain, that is equal to the sum of the complex conjugate, the amplitudes multiplied by amplitude of p sub s by a star of p sub s, which you can easily work out for yourself, which that confirms p sub s also as a random variable, a discrete random variable with probability a star a. So this is what Saxon says is the heart of quantum mechanics, is this next step too. These, by the way, are not axioms. These are just theorems from so that the statement that the de Broglie wave is the heart, the rabbit in the hat of quantum mechanics, is, I think, that's the only thing you have to have. It's an austere, timeless statement of quantum mechanics. I'd like to go on and on and on, but that's probably enough. I hope I can encourage some of you to eventually look at my website, which will be somewhere sometime. And maybe, could this be water? Thank you.